And my board is always haunted no matter what room I'm in. Okay, these guys, we did this one in class, didn't we?
Yeah.
We did this one in class. This label, X and Y, this is your special triangle. Okay, this one over here, when you do this, notice, even if you did Pythagorean's theorem, you're going to break this down. They can all be divided by 2. So this actually is your special triangle, your 45-45 triangle. 1, 1, radical 2. So it's a triangle that you're comfortable with as well. It's easier to reduce them here than it is to come down and have to reduce it 6 times. Okay? Everybody good with this? Questions? You're good? Especially my triangles, you have to know those guys. All right. Angles in standard position, again, don't forget they open up from the positive x-axis. They go counterclockwise. Take this point, because it's a point on the circle. The reason we say this is because it's a point on your circle. So this is your x, this is your y. If you recognize your triple, you don't have to do Pythagorean's theorem. There's only a few that are really, that work out perfectly. So you don't have to memorize them. You can always find them with Pythagorean's theorem. Once you find that, take your pieces, and you should be able to find your sine, cosine, tangent. Same with, I know we did one of these. I think we did 17, right? We did one with the negative in it.
No, we did the other one.
We did this one?
No, we did the one with the negative.
Yeah, we did that one. These, everybody okay with these?
I like those.
Yeah. You can even pick an angle from each one and try an angle in it if you're confused on where to go. Okay? I had to tell you what quadrant it lies in. I think we did this one. Because sine is positive in 1 or 2. And that's going to affect the x-axis, the x value. So we said this one was in quadrant 2, which made your cosine and your tangent negative. I find it much easier to do this, to make this little information box. If you find it easier, I think it's easier to do that. You never look back at your triangle. You never have to go back and say, all students take chemistry. I find after kids do all that work, finding all the values, they forget the positives and negatives. So if you build it right into your x and y, it takes care of it for you. And it makes, I think it makes more sense. Your unit circle is superimposed here on your axis. So this is where x is negative. So that would make sense that the cosine is negative in 2 and 3. This is where y is negative. That would make sense that your sine is negative in 3 and 4. So use the axis behind it. Okay. Again, we have tangent, and I said sine is negative. So you have to locate where is tangent negative and sine negative. That would be quadrant 4. So your triangle exists, your angle exists in quadrant 4. And set that up. Good? This one we told you between 0 and pi. So 0 and pi is 0 to 180. And where is my cosine negative? In quadrant 2. Okay. Set up your triangles. If you're more comfortable at this point, flipping this over. Oh, this is great. No, it's not working at all. If you're more comfortable flipping this over, well, take the cosine of this angle, negative 2 over 1, and flip it to 1 over negative 2. I have no idea what this is doing. No idea. It's fine here. I must have to set my board. Okay, cotangent is undefined.
That means the denominator is 0.
It means the denominator is 0. So if my cotangent is x over y, that means I'm looking for a y of 0. That means I'm looking for either here or here. because cotangent is x over y. So I'm either looking for one of these guys. And they told us between 90 and 270, between pi over 2 and 3 pi over 2. So I want this guy. I want pi. Okay, easy way to start that. Everybody okay with that?
Yep.
Stop me if you have any questions.
Oh wait, I have a quick question.
Yes.
So even though, whoa,
I'm telling you, my board is haunted.
so how would you know if like cosine is positive or negative?
Cosine?
Or wait, never mind, that was a dumb question. I answered it. I got it.
Okay.
I got it.
Did you mean on the quadrant angles?
No, I got it.
Okay. All right.
If I explain, I'll just
It confused me.
Yeah.
It's okay, as long as you get it. Sometimes you have to think out loud.
Yeah. I just have to ask stupid questions.
No, it's not a stupid question. Sometimes it makes you think a harder one you have to break down to a very easy one. Okay, now these are kind of a mixture. I threw some angles in degrees. I threw some angles in radians. I did some negatives. And see where they turn out. 225 terminates in quadrant 3. There's your 45-degree angle. Okay, so I just asked you for the 3 basics. Everybody good with that? Exact values, no calculators. 750 negative, that means it's starting here. It's going around 360. So if you could take 720 is its second 360. So I went around 360 and I went around again to 720 and I went 30 more. Okay, so I terminate in quadrant 4. Then, if you're not sure, check it on your calculator. Put in your calculator, put it in degree mode, and put in sine of negative 750. And it has to come back and give you the correct sign. You can always check it. You can flip your calculator from degree to radians. If you have a radian measure, put it in radians. Okay, 5 pi over 3. We said this is 3 pi over 3. This is 6 pi over 3. So as we come around, 5 pi is 1 short of 6 pi. Again, there's your special right triangle. 3 goes into 180, 60 times. Are we getting a little?
2 goes on the hypotenuse for that? I always mess that up.
The 2, if you do 1 radical 3, then the radius is 2.
Oh, I thought the
It was
Hot.
1. Because it was a unit circle.
Well, if you want it on a unit circle, then that would be 1. This would be 1/2. This would be radical
You
3
don't
over
have
2.
to.
You didn't have to. You didn't have to put this on a unit circle. But if you want it to, then your unit circle says this is 1. This is radical 3 over 2. This is 1/2.
So the hypotenuse is not square root.
Never. Because the square root of 3 is 1.7 something. It would be smaller than 2.
Alright, I messed that up.
Here's an easy way to remember this. Watch.
Watch.
The smallest angle, give it a 1. Okay? What is 3 squared? 9. So opposite the 90, give it a 2. 1 and 2 is 3, but it can't be bigger than 2. You know, you got to find a silly way to remember it,
Okay.
and then it helps you remember it.
I always just mess that up.
If you go to a unit circle, remember, you're going to divide everybody by 2, which is absolutely fine. I don't care if you work in the unit circle or whatever radius you make your circle, whatever triangle you remember best. If it says unit circle, do like we did the first day. Make yours and then divide it by 2, or whatever it is you call yours. But usually by the time you reach up here, you have your own little methods of figuring these things out. Good?
Yeah.
Okay. These are really important. I kind of mixed them up a little bit so you'd have a little bit of everything. Okay. And the last 3, negative pi over 6 terminates in quadrant 4. 6 goes into 180 30 times. There's your special right triangle. Pi over 4, 4 goes into 184 times. Remember, this is coming around again. This is starting here, going to 4, going to 8, add 4. This is 12 pi over 4. Well, I'm at 11, so I'm 1 short. If you struggle, convert it.
On the test that we had, do we have to draw the picture?
Well, because, yeah, I need to see your sketch. I need to see what parts that you terminate in. Otherwise, you can just look it up on your calculator and then just, if it's 707, you can just give me 1 over radical 2. So I need to see the sketches where they terminate. Okay, this guy started out negative. Just work your way negative. 6, 12, this guy's 18. I'm 1 short. And if you struggle, convert this. Just convert it. Convert it, find your degrees. And then do your degrees and figure it out that way if you have trouble. The bottom number should give you your reference angle. So I need sketches, I need special triangles, quadrantal angles. This never recorded.
Yeah.
Applications. Very, very basic applications. And you probably remember these from Algebra 1. A 100-foot line is attached to a kite. When the kite is pulled taut, the angle of elevation to the kite is approximately 50 degrees. Find the height of the kite to the nearest 100. When we ask you to round, that means you're going to be picking up your calculator. And 50 degrees, is that one of your special triangles? No. So you're definitely going to be picking up your calculator. Now, draw a picture. So here you are, flying a kite. Doesn't like that side. Oh my goodness. I honestly don't know what's going on here. Whoa. Sorry. Okay, draw me a picture, guys. See if you could sketch a picture while I figure out what's going on here. Guys, focus on this. Let's go. Draw me a picture. What does my picture look like?
Triangle.
A triangle. What kind of triangle?
Right triangle.
A right triangle. Okay. I'm just going to call this ABC. Well, how do I know it's a right triangle?
Because
What part represents the strength of my kite?
hypotenuse.
The hypotenuse. So, here's my kite up here. I'm flying my kite. I want the height. How do I measure something height-wise? I drop a perpendicular line. Right? I drop a perpendicular down and measure the height. Makes a little H. Okay. So where's my angle of elevation? What angle? A. And I want the height of the kite. So where does the 100 go? God bless you. This is the line of my string to my kite. And which segment do I want as my height? BC. Everybody okay with this? Okay. What trig function would I use with this 50-degree angle? Sine. So I take the sine of 50. Opposite over hypotenuse. And how do I solve this? Just cross multiply. Multiply by 100. Make sure your calculator is in degrees.
You use the sine 90. Use 90.
Why would you use 90? No, tell me why.
It's across from 100.
Yeah, we usually use these guys. because these are your reference angles, never the 90. If you were doing law of sines, you would probably use the 90. But we don't do any law of sines or law of cosines in here. And they took it out of algebra 2. Law of sines, law of cosines is now in geometry.
What?
Yep. Now in geometry. It kind of makes more sense because they do some trig in geometry. They do a lot of trig in geometry now. They do trig in geometry, like they do some in algebra 1, but mostly in geometry. What's this in? Degrees. So to the nearest hundredth, what do you get? So what would I label this as? Feet, yards, meters? Feet, because I'm talking 100-foot line. So if this makes sense, you want to make sure it makes sense. It's less than my hypotenuse, and that's what I want to make sure of too. Okay?
Okay.
So sound good?
That was easy.
Okay. So I want you to read and set up the next one. Set the next one up. This is a tougher one. This is one off your regents.
This isn't.
So what function are you going to use? Tangent. How many tangent statements do you have to use? Two. So let's do the first one. Let's do the total height. It's easier to do this in words first. So what's the total height? The tangent of what angle?
53.
Is equal to what? X over 200. Okay, so we're calling this big guy right here X. All right, just cross multiply this. Don't figure it out yet. So we know this guy right here is 200, tangent of 53. Now, the height of the building. What's the height of the building with tangent? Is equal to what? We'll call this y. Y over 200. So again, just cross multiply this. So let's subtract this. Shouldn't this give me the smokestack? Yes. So throw it in your couch. And to the nearest 10, find the height of the smokestack. Everybody okay with this? Yeah, it's pretty big, isn't it? How big is it? 0.4. It's pretty big. Questions? We had to do it twice. They like this question on your regions, they like the one with two sailboats. And one sailed a little further away and looked at the lighthouse, and one was closer to the lighthouse. Same concept. Same double right triangles. Okay. Now this next one, I took this out of the book, but it is not drawn to scale. So clearly this is not drawn to scale right here. Okay, a space track A spacecraft is traveling in a circular orbit. Here it is, around the Earth. This is part of your circle right here. This is part of your circle that it's traveling around. Find the angle of depression from the spacecraft to the horizon to the nearest tenth of a degree. They want this guy right in here. Assume that the radius of the Earth is 4,000 miles. Okay, so this is totally not drawn to scale. Now, when you do an angle of depression is you're standing here. You're looking down. This is your angle of depression. If you set this out like this, and you run this transversal, this angle of depression is actually equal to this angle of elevation. Why? Why? Alternate interior angles. So, this angle of depression is going to be the same as this angle of elevation right here. I like the concept of this. The diagram itself was horrible because this doesn't even look, this looks like where the right triangle is, not here. But this is from the book, so I don't know. I figured we could, I like the concept of this because you have to find, you have this piece. If you take a look at your triangle, you have this piece. You know this is 4,000. You know this is the angle you're looking for. And you have your hypotenuse. How big is my hypotenuse? It is, because this is the right angle. See it?
Yeah.
The triangle is, yeah, it looks like it would be on the other side. That's why they completely said not drawn to scale. I don't know, how big is this hypotenuse now? If from here to here is 150, I need to know this whole thing.
Oh, so it would be 4,150.
Okay, so your radius is 4,000. So your hypotenuse is going to be 4,150 miles. The diagram is horrible, but the concept of it I like.
I thought you were talking about the same line. I was like, you just said it's 150.
Right, but the hypotenuse goes this way.
Yeah, I know. I was just saying because I didn't realize that it wasn't talking about like is it Earth too.
Right. That's why I like the concept of this diagram because it makes you think, well, where do I get this other part? That's my radius. This is your radius right here. That's your radius. They gave you from here to here was 150 miles. Then from here to here is 4,000 miles. Okay, your angle of depression, your triangle looks a little strange here. Your angle of depression, they kind of worked out the other side of your right angle. But it is the same as if we took it over here. So we're just going to consider our angle of depression as our angle of elevation. So if you're not too fond of the diagram, I get it. I wasn't fond of the diagram, but I was fond of the concept. Plus we had to find an angle. So if you figure out your angle, how do I find my angle?
Why are we doing cosine?
Because we have an adjacent over a hypotenuse.
Oh.
The triangle is a little strange looking.
Are we finding that angle because it's equivalent to the angle of depression?
Yeah, technically, this is where your angle of depression should be, but they're working on the other side because your triangle is way off, but the concept is there. So how do I find an angle when I have both sides? Cosine inverse. So again, make sure you're in degrees and round this to the nearest tenth of a degree. What do you get? 15.5 degrees. Again, I wasn't fond of the whole diagram, but I did like the concept of it. And I do like this last one. Now this last one, well, find me that line. Where does that line go? Where is the line y equals negative x?
It's like y equals x except it's negative.
You're right. Here's your line y equals x, What does the line y equals x do? Like, what's this point? What's this point? What's this point?
Oh, it's a 1-to-1.
Yeah, it's equal, right? Doesn't it cut this exactly in half?
Yep.
So, like Ashley said, I'm really looking for this line because it's negative. So the concept is still the same. Doesn't it cut this in half?
Yep.
What degree angle is this? 45. It's a 45-degree angle. So this one's not too bad. We can figure it based on a 45. Or if I gave you this with a negative 3x and negative 2x and negative 20x, whatever this is your slope. So slope is what values? Change in y over the change in x. So even if I said this, y equals negative 3x, excuse me, my y would be negative 3, my x would be 1. There would be the pieces of my triangle. So this was kind of nice because I know what that is. So there's your 1, 1. So x is negative 1, y is 1, and r is radical 2. Can you find all your values based on that?
Yep.
Sometimes this was nice because it cut it right in half. Sometimes it won't cut it in half. We can use the slope as well. You can do the slope of it as well.